Good morning, my lovely kiddos and my future mathematicians. Today we are talking about 7.4a, properties of special parallelograms. All right, so just a quick reminder before we go ahead and get started. The 5 cool rules for every parallelogram are: our opposite sides are congruent, our opposite angles are congruent, our opposite sides are parallel, our consecutive angles are supplementary, meaning they add up to 180, and our diagonals bisect or cut each other in half. Okay, so everything we will talk about today will have these 5 super cool rules in addition to some others. Okay, so the first shape, our first special parallelogram, is called a rhombus. Okay, so a rhombus, just like I said, we'll have our 5 super cool rules. Let me draw a picture of a rhombus here. So it will have our 5 cool rules. And then our new rules for a rhombus, the new properties here, is that all 4 sides are congruent. Okay, so this is something unique to a rhombus that is not for every parallelogram. All 4 sides are congruent, so I will add a tick mark once on each of the sides. And then the second new property is that the diagonals are perpendicular. And I could fit it. Awesome. Okay, so the diagonals, or the segments here that are connecting the angles that are not already connected, although they do bisect each other still, because that was one of our 5 cool rules, now they are also perpendicular. Okay, or they intersect at 90 degrees. All right, remember that this means that we would have the opposite reciprocal for our slope. We might have to test that out later. Okay, our second special parallelogram here is a rectangle. Okay, I'll draw a picture of a rectangle here. A rectangle, because it is a parallelogram, it will still have our 5 cool rules, but then it has some on top of that. So, for a rectangle, the new property is that all angles are congruent and 90 degrees. So all 4 of our angles are going to be right angles. So they are all congruent and they are all right angles. And then our second new property for rectangles is that our diagonals are congruent. Okay, so this diagonal would be congruent, equal to, or the same to this diagonal. Okay, and since they bisect each other or cut each other in half, that means that each of the halves would be congruent as well. And then our final new parallelogram here is a square. Okay, so I'll draw a picture of a square here. Now, because this is a parallelogram, a square is going to have our 5 cool rules. And the square is very special. It is going to have all the properties, of a rhombus. Okay, so we said that with our rhombus that all 4 sides are congruent and the diagonals are perpendicular. So squares will have those new characteristics. So I'm going to draw our tick mark showing that all of our 4 sides are congruent. And I am going to draw our diagonals in here and then draw a 90-degree angle, because our diagonals are perpendicular. Okay, squares also have all the properties of a rectangle. I'll just abbreviate that. So in our rectangles here, all angles are congruent and 90 degrees. So that means that in a square, all of our angles are congruent and 90 degrees. Okay, and that our diagonals are also congruent. So I'm going to add some tick marks onto each half of our diagonal here because they do bisect each other, so the two halves would be congruent on both pieces. Okay, so we have a lot of rules for our square and some new rules for our rhombus and our rectangle here. So let's go ahead and dive into some examples. All right, so in this first example here, we can see that we have a shape, a parallelogram here, and we know that all four of our sides are congruent because we have our 4 tick marks. So we take a peek back at the sheet we just put down, all right, and we look at which shapes or which parallelograms, which new parallelograms have all 4 sides are congruent. Now this is the rhombus and the square. Okay. However, in our example, we don't have anything about the angles. So it cannot be the square because all of our angles are not congruent and 90 degrees. So this shape must be a rhombus. Okay, in this example, it has already been classified for us. They tell us that this parallelogram is a rectangle and they want us to solve for x. I notice that our x's are on the 2 pieces of the diagonal. So let's go ahead and look at our sheet again. And remember that a rectangle, that our diagonals are congruent. And since our diagonals are congruent and they bisect each other, all pieces of our diagonals are going to be congruent. They are equal. They are the same. So we could set these 2 algebra pieces equal to each other and solve for x. So we just have 2x is equal to x plus 5. I want all my variables on the same side, and to avoid negatives, I'm going to move this smaller quantity. So I'm going to move this 1x. Since it was positive, I subtracted 1x, once on each side of the equal sign. 2x minus 1x gives us a positive 1x. 1x minus 1x, those are going to cancel because they add to 0. And then we bring down that 5. So x is equal to 5. All right, our third and final example here, we have a sentence. It says, this shape, or it, has 4 congruent angles and 4 congruent sides. And then we would have to circle which of our special parallelograms, or just parallelograms overall, apply to this rule. So looking back at our sheet, okay, so we want to look for something that has all congruent angles and all congruent sides. So a rhombus has all congruent sides, but not all congruent angles. A rectangle has all congruent angles, but not all congruent sides. And since a square has the properties of a rhombus and a rectangle, this would have all congruent sides and all congruent angles. So the answer to this, it has 4 congruent angles and 4 congruent sides, will be this is a square.